Okay, so there we go. We good with that? So on number 1, so the Pythagorean Theorem, a squared plus b squared is c squared. And use your calculator. Okay, they want you to find the a there. So same thing, Pythagorean Theorem. A squared plus b squared is c squared. So try that. Solve there for the a. So I'll plug stuff in. B is 9. C is 15. Then I got to find A. Good so far. $225, I think, right? Now, how do you solve that for A? What are we going to do to solve for A there? Yeah. So what's my next step? Subtract the 81, huh? So what's that? 144, thank you. And then last step to finish solving for A. What do we do to turn A squared into just normal A? Square root. A is 12. A is 12. How are we doing? Questions I can answer on that? All right. So try that one, see if you can find A there. A squared plus b squared is c squared, the Pythagorean theorem. So let's put in the, we don't know A. B is 4. C is root 27. And then we square that, huh? Good so far? So I just plugged in the B and the C. B is 4. C is root 27. Okay, now this is 16. What's the square root of 27 squared? Yeah, these just cancel, and it's just 27. We good with that? Remember that roots and two powers are opposites of each other? They cancel each other out. That good? So now what do I do to finish solving for A? A said I want to be alone. So subtract that 16. So these cancel. A squared, so it's at 11. And then last step to turn it into like a normal A instead of an A squared. Rooted, huh? A is the root of 11. Yeah, they want root of 11. That's the exact answer. They want you to also hit the buttons on your calculator. It's going to be 3 point something, isn't it? 3.3166. And then, yeah, they say 3 places. I want you to round to 3 places. Remember how rounding works? You circle the place they want you to stop at, third place, and you look 1 to the right of that. If it's 5 or more, you go up, huh? So 3.317. There's the rounded answer, the approximate answer. So they want both. The exact answer and the approximate answer. Questions on that one? We all good? This easy for you so far? Yeah, Vincent.
What number were we rounding up to?
Yeah, well, they told us 3 places. Yeah, round to the nearest thousandths. You know, 1,000 has 3 zeros. So 3 places. So they want you to round. So I circled here the third place. So when you round, you circle the place they want you to stop at, third place. I looked 1 to the right. If the one to the right has 5 or more, you know, you go up. On that. Yeah, Alexis. Yeah, it does. Yeah, so see how here, but here's the question. They say type the exact, so that's the square root of 11, using radicals as needed. They want you to type in root 11. And then down here they want the 3.317, the approximate answer, rounded to 3 places. They want them both. Make sense? Questions? All right. With that, today, in a couple sections. Here we go, guy wire. How long is a guy wire reaching from the top of a 6-foot pole to a point on the ground 4 feet from the pole? So here's a real life application. Suppose you were building something like, and you were going to have, it's always good to draw a picture of what they're saying. And, you know, I could whip it out real quick. Let me let you, okay, let me help. So basically, it doesn't matter if you go right or left. So you got a pole that is 6 feet tall, right? How long is it going to reach from the top of a 6-foot pole to a point in the ground 4 feet from the pole? And then, so then the wire is going to go like at here. This is 4 feet to point on the ground 4 feet from the pole, right? Like that. And then the wire goes down like, there's the wire going down like that. Does that make sense on that? And they want us to, and they say, how long is the wire? So that's our X, you know, you're trying to find whatever you want to call it. C, if you want, same thing, doesn't matter. Trying to find how long that wire is. Let's call it W. How about W? Meaningful letters sometimes are more helpful. W, so we know when we find it what we got. So, are we supposed to use the Pythagorean Theorem? Absolutely. How do you know you're supposed to use the a squared plus b squared equals c squared? Is it every triangle or certain kind of triangles? Yeah, because we have this 90-degree angle. Wait a minute. How do we know we have a 90-degree angle there? Yeah, because I drew it that way. Well, yeah, we're assuming that top of a 6-foot pole. Yeah, we're assuming the pole goes straight up. We're assuming it isn't the leaning tower pole, you know, or something weird. So we're assuming that went straight up. Yeah. So then that'd be a 90-degree angle. So anytime you have a triangle with 90 degrees, like a T, right? That 90-degree angle, like a corner of the room or something. 90-degree angle. Anytime you have that, you can use, they want you to use Pythagorean Theorem. It's just always what they want. A squared plus b squared is c squared. We use Pythagorean Theorem. Whenever you have a right triangle, use Pythagorean Theorem. Now, how do you know? Up to now, they've been telling us A is this, B is that, C is this. How do we know which one's A, B, and C? Well, actually, you don't really need to worry about A and B. The only one you need to focus on is C, because A and B, the order doesn't matter. You can totally interchange them. It's just make sure that C is alone. That's the only thing. Make sure that the C is the one that's alone. Now, which one is C? Well, C, in this case, is the wire, isn't it? It's always the one across from the right angle. The longest side, the diagonal side. That's always C. See how it's longer than the other two? So the other two squared add up to equal its squared because it's bigger. So as long as you get the correct one is C, the other two, it doesn't matter. So you could go 6 squared plus 4 squared or vice versa. You know it doesn't matter which order you add. It'll work out the same, but make sure the W is the C, or you could just call it C. All right, what do we got? 36 plus 16 is W squared. 52? 52 is W squared. And then bring it over here. So 52 is W squared. Last step to get W. Root it. W equals. Type an exact answer. Will they take root 52? I think we have to simplify that one, don't we? I don't know. I'll just let you leave at root 52. Even though that could be simplified, they're not going to bug us about that. Root 52 is fine. And then they want the calculator also. Did y'all get it in your calculator? 7 point something? There it is, 7.211. Yeah. We good? That's the second answer. the rounded approximate answer. So it's about a little over 7 feet. So there's a very practical question. If you were putting a 6 foot tall thing, you want it to go to the ground 4 feet. How long does it have to be? 7.2 feet. How long? You got to make the wire. Good there? Questions on that? So let's try even a more practical. Here, taking a look at number 5. So they're building a bridge. Let's suppose some engineers, do a little engineering now, are building a bridge. You know what happens when you heat up a metal? Let's say they're going to make a metal bridge. They have steel in there so cars can go, strong. What happens when you heat up metals? They melt. I guess a lot of things happen. They melt. And they also expand a little bit? Right? When they get warmer, when you heat up metals, they actually expand a little bit, don't they? They get a little bigger. Right? Most things, when you heat them up, they actually expand a little bit. They get a little bigger. Well, what important thing do you know when it actually expands when you freeze it instead of heat it up? It goes the other way. Water. Yeah. You know what happens right when you freeze? Right? You've heard about those old experiments. They say fill up a soda can or a water bottle and right to the rim, close it, put it in your freezer to freeze the water overnight. What'll happen? It'll explode the plastic can, because when water freezes, water actually does the opposite of what most chemicals do. When water freezes, it expands. It gets bigger in its frozen state. Most chemicals, like all metals, pretty much, I'm no chemist, but virtually every metal, they expand when you heat them, not when you freeze them. But water, when you freeze it, it expands, and that is so important for the earth to exist and for life to be on the earth. Why is that? Why is it so important that ice expands? When water expands when you freeze it into ice. You ever heard biology or chemistry talk about that? Why that makes life on earth possible? And it's a very rare thing. It's a very specific thing in the angle at which the H2O molecule bonds. It's, if ice didn't do that, if water was like most chemicals, and when you froze, the frozen state was actually shrunk, then that would make it more dense, right? When something expands, it's less dense. You know what I mean? Like thickness, kind of like density, it's like thickness, heaviness per unit volume. So I'm doing a little chemistry here, huh? Anyway, because it expands, that's what makes ice float in drinks. That's not what saves the world. But that's why ice floats in drinks, because ice is less dense in the frozen state than water. If it was more dense, it would go to the bottom of your cup. Right? What makes ice float in a drink? Now, who cares about ice floating in drinks? What floats in the oceans in the frozen state? Icebergs. Like all the glacier icebergs, if in the frozen state, if they didn't float in the water, if ice instead got more dense in the frozen state, all the glaciers would sink into the ocean, and the ocean level would rise and flood the entire earth. There would be no land on the earth if it wasn't for that chemical principle designed just right to make life on earth possible. Anyway, so getting back to the metal bridge. So in the summer, if they build a bridge out of metal, and well, let's say the winter or whatever, the winter, they build a bridge out of metal, and they make it exactly right, and they weld down the two sides, and then that's the winter. And then summer comes along. What's that bridge going to do? It's going to get a little bit, not a lot, right? Metals just expand a little bit, but it's going to expand a little bit, and yet it doesn't have room to expand. If the engineers built it in the winter, and the bridge tries to expand and push out, what's going to happen to that bridge? It might break. It might. What happens to if you take? Let's say this piece of paper here is my bridge. Okay, right? They build it in the winter tight, and then they weld it tight on the two ends. And then summer comes along, and the bridge tries to expand, right? Because it's heated now, especially in Fresno at 100-degree temperatures, right? The bridge tries to expand when metals expand when they're heated. So what's the bridge going to do if these are tight? How's the bridge going to have more length and still be at the same ends? What's it going to do? It will pop up, won't it? Right? That way it's longer now and still welded at the two ends. The bridge will pop up. That's what they're showing in that diagram. See the bridge popping up in the summer heat? Because there's more length to the bridge now because of the summer heat. Metals expand in the summer, in the heat. So the bridge is going to pop up. Now the reality is engineers have learned about this. And so they put expansion joints in metal bridges now because of this very issue. They found that in the summer when things heat up, the bridge tries to expand, so they don't weld it tight on the two ends. They put expansion joints so it has room to expand and still stay flat. Because otherwise, it would pop up. Well, how much would it actually pop up? I mean, let's take an example of a 4-mile bridge. So that's a long bridge, right? We got a 4-mile bridge. That's where it seems like every time I go through the Bay Area, I pay tolls. And all the bridges are tolls, it feels like now. So some big long toll bridge, 4-mile bridge. And let's say now the metal doesn't expand very much. Let's just take, for instance, 4 feet in length. So it's only expanding how long is a foot? About that long, right? 1 foot for every mile. So 4 feet for 4 miles. That sounds about right. Metals don't expand very much. So 1 foot for a whole mile, so 4 feet for 4 miles of bridge. That's probably realistic. That's probably how much it would try to expand. Now 4 feet, what's 4 feet? About that long? 4 feet expansion in a 4-mile bridge. Think how long that bridge is. It's 4 miles of metal. It's going to expand, it's going to get longer by only 4 feet during the summer heat. How dramatic of an effect could that be? Won't it just make the bridge go up just a little bit? Where you could, is it really an issue? I mean, do they really have to put in expansion joints? What if they just welded it tight and say, yeah, it's going to pop up a little, it's just going to barely go up. Nobody will even notice, right? Just barely up and up. It's 4 miles long. 4 feet is not much, right? 4 feet expansion is not much in a 4-mile bridge. It's going to, nobody will even notice. Probably just up a little bit. Nobody's going to notice. Is that true? Let's calculate it and find out what the truth is. We'll be like an engineer here. All right. So here's how we will calculate. We can do it with the math we've learned now. So here's the bridge in the summer. It's 4 miles. That's winter. That'd be the winter, right, when it's not expanded. And then, so I should make the blue the winter, huh? I'll try to be color sensitive here. So there's the winter in the blue. And then here I'll do orange in the summer heat. So in the summer heat, the bridge is going to, I'll make it look more dramatic, but it's going to pop up a little bit, right, in the summer. It's going to get longer. So I'll just put the dotted line down there. Basically, it's going to make a couple right triangles. See, this is a right triangle. See how we can do it with our right triangle stuff? It's going to make 2 right triangles, isn't it, when it pops up? Now, this part right here, this is 2 miles, from there to there. And from there to there is 2 miles. You agree? So far, so good? Well, I'm just cutting the bridge in half because it's 2 right triangles. You might wonder, well, why are you cutting it in half? Yeah, maybe I should say why. Why don't you just use the whole triangle? Because the whole triangle is not a right triangle. The whole triangle doesn't have a right angle, does it? See how the whole triangle doesn't have a 90-degree angle. So I can only use the Pythagorean, a squared plus b squared is c squared, if I make a right triangle. So I'll split it in half, making 2 right triangles. Now I can use the Pythagorean theorem. Everybody see why I'm doing that? And so that means I broke the 4-mile bridge into 2-mile, 2-mile. How long is like this piece, and then the other piece is the same? How long are each of those? Well, that's the longer pop-up in the summer. Well, how much longer did it get in the summer heat? 4 feet more, right? That's what they said here. expands 4 feet in length during the summer heat. So it's only longer by 4 feet. So before it was 2 miles, now it's going to be 2 miles plus 2 feet on this side and 2 miles plus 2 feet on that side, right? Total of 4 feet extra in the pop-up version.
So, where you have the right triangle, the little square from the bottom to the top, that's not 4 feet?
No, they're saying the length of the bridge grows for. We want to find what the pop-up is.
Oh, okay.
Yeah, the bridge itself gets longer by 4 feet.
So
Good question, Claudia. Yeah, they're not saying it goes up 4 feet.
All right.
They're saying the bridge, the length of the bridge. So it'd be like if you had a metal rod, like what if this was made out of metal? And I took a welding torch, right, and I just heated it up, the thing would get longer. I mean a little bit, just a little bit longer. The metal would expand. That's what we're saying. So the metal bridge under summer heat gets longer, but when it gets longer, it actually pops up if the 2 ends were welded tight, right? It would have to pop up to be a longer length connecting the same 2 points, right? So it grows by 4 feet, so I just gave it 2 feet on each side. So originally, in the winter, it lays flat, 2 mile, 2 mile, 4 mile total. Now in the pop-up summer, it's 2 mile, 2 feet, 2 mile, 2 feet, 4 mile, 4 feet, all together in the pop-up version. So the question is what Claudia was mentioning, how high is the pop-up? Right? I mean, because if this is super tiny, which we're thinking it should be, I mean, the bridge only got 4 feet longer. How much could the pop-up be? The bridge, it's a 4-mile bridge. It only grew in length by 4 feet. So how much is the pop-up going to be? How much could it be? It's going to be some tiny little number. Nobody will even notice. Don't worry about it all. Maybe. Let's see. Call this X. Trying to find out what the pop-up is in the middle. So this is a little right. So I'm just going to do the right triangle on the right. You can do the one on the left. It doesn't matter. Makes sense? I got a little right triangle there, don't I? So I'm going to do the a squared plus b squared is c squared. Okay. Now remember, when you set these up, doesn't matter the order for a and b. You just got to make sure you get c right. C is the one that's longest. So for these 3 sides, this side, and this side, which side is C? Which side is the longest? Yeah, this one, that's C, isn't it? Because that's the longest side, the diagonal side. So that now, dude, you got to know. Does anybody know? I'd be impressed if you knew. 1 mile is how many feet? 5,280. Wow, you know. All right, 5,280 feet in a mile. So therefore, 2 miles. So you got to go 2 times 5280. Then you got to add 2 because we're going plus 2 feet, right? So somebody got that 5280 times 2 plus 2. So this is going to be 10,562 feet. This one down here, 2 miles, is just 2 times 5280, which is 10,560 feet. So we had to convert it all into feet. We can't have miles and feet mixed, you know what I mean? You got to make everything feet. So I just used 5,000, and you don't have to know that. If I put this question on the exam, I will give you that fact. There's nothing valuable for you to walk around knowing. I mean, it's good if you know it, but not required. 5,280 feet in a mile. So I just took 2 times 5,280, 2 miles, add 2, right? The top is expanded 2 feet on each side, 4 feet total. So that came out 10,562, whereas the bottom is just 10,560. See, it doesn't have the extra 2 feet. So each half of the bottom is 10,560 feet because that's 2 times 5280. And each top of the half, each half of the top is 10,562, 2 more feet. All right. So anyway, C is 10,562 squared. A squared, I'll just say that's x squared plus, and then the B is 10,560 squared. We good there? See what we're doing? Those are big numbers. Definitely want a calculator. So x squared 10,560 squared. Ooh, that's a big number. 111,513,600. 111. What is that? 111. That's million, huh? And the other side, 10,562 squared is 111,555,844. So they're both huge numbers. We good so far? Does everybody see what I'm doing? Claudia, question?
Okay, I see that.
This makes sense? I want you to track with me, y'all. Is there anything I can answer? So I'm just taking half of the overall bridge. So the bottom half is 2 miles. Multiplied 2 times 5280, 10,560 feet. The top is the pop-up, so it's a little longer by 2 feet. So add 2 to that. 10,562. Put them in the Pythagorean a squared, b squared, c squared. How do you solve for x here? Yeah, subtract that big old whopping 111, 513, 600, 111, 513, 600. X squared equals, I don't know, some big number. I'm getting 42,244. How we doing? Good so far? Bring it over here. Almost done. X squared is 42. We're almost done with our first engineering problem. I don't know if this is maybe your first engineering problem or not. And then last step, to finish solving for x there. Root it. And I'm getting x equals 205. 205.5. I don't know how far they 5.3. How far do they want me to round? The exact height of the bulge. They want the bulge in the middle. So that would be the square root of, wait, what was it? Square root of 42,444. So there's the exact answer. Let me see. Oh, they want one more decimal. 205.533. You all getting that? Stop for a second. And that's what? What are the units on that? Feet, huh? That's feet. I told you my old physics teacher always wants units, right? Yeah, so feet. So that means the bulge in the middle is, how big is the bulge in the middle? 205 feet. Are you getting that? Let's let that sink in for a minute. If you weld the ends tight, don't put any expansion joints. And summer heat comes along, and that bridge gets 4 feet longer, thus has to pop up to cover its length. That pop-up in the center won't be tiny like nobody notices it. It'll be a 200-foot pop-up. Do you realize that? That's like 20 stories. Right, a story's 10 feet usually. Maybe less. It's like 15 to 20 stories. That'd be a 15 to 20 story pop-up in the middle. That'd be like an amusement park ride, is what that bridge will become. Realize that? That would be craziness. Is that right? Does that feel right? It feels almost crazy. But if you think about the physics, I enjoy physics. I'm helping my daughter with physics right now. It's always very painful, but it is super satisfying to see how the laws that are in the universe work together. They're pretty neat. They're tricky. They frustrate me, but when you get them, it's like, oh yeah, that's neat. Anyway, think about how much I have to move my fingers in to get a big pop-up. I can't control paper very well. Not much, huh? Just barely move my fingers in. Just barely, and I get a big old pop-up. How far? Look, I barely move them out. Big effect in the middle. Barely move them in. See, just a little bit on the outside makes a huge effect in the middle. That is right. Just a little bit expansion. huge pop-up in the middle. That is how the physics work. That's the truth. So if they don't put expansion joints in there, this is going to become craziness in the middle of the bridge, won't it? So big lesson for engineers is this, and it's the math, that the little Pythagorean theorem that tells us how this works. Now, all right, let's try that one. So the diagonal of a square is length 3 root 2. I'm not doing very good. I didn't even capitalize the beginning of my sentence here. Find the side of the square. So I think it would be helpful to draw a square. And they're telling you the diagonal right through the middle is 3 root 2. So draw a square, put the diagonal on there. That's 3 root 2. See what you can find. Does that make sense? We got a square. The diagonal is 3 root 2. And they want you to find the length of the side. Call it like x. And if it's a square, all the sides are x, aren't they? Because a square, all the sides are the same. So do we have a right triangle? We have a couple of them. You don't even need the top of the square, do you? If you want, you can just like erase the whole top part. We don't even need it. There's our right triangle, huh? Let's go ahead and use Pythagorean Theorem. A squared plus b squared is c squared. Okay, so a squared plus b squared is c. So remember, the main thing is knowing which one is c. So which one is c? This side, huh? Yeah, the longest side, that's got to be c because he's the longest side. So that's the 3 square root of 2. And that whole thing is squared, right? Because c squared. The others are both x, aren't they? Does that make sense how I plugged into the Pythagorean? And now, what is x squared plus x squared? Good, yeah. It's not x to the 4th, is it? That if we were multiplying, if we were taking x squared times x squared, that would be x squared. But when you add them, you just add the invisible ones in the front, getting 2x squared. Remember that? Remember how you add letters as opposed to multiplying letters? When you add letters, you don't change the powers at all. You just add the numbers in the front. Claudia?
And the reason we don't use A and B is because the square has even.
Yeah, they're all the same. So you could use A and A because they're the same. Yeah, so we don't want to use two different letters when we know they're actually equal to each other. So A and B are equal. So you could use A and A or B and B or X and X or Joe and Joe.
Because it's a square.
Because the sides are the same. Because it's a square. Exactly right. Yeah, that's important that it was a square. If it was a rectangle, then A and B, because we wouldn't know. Yeah, but it's a square, so the sides are equal, so we use the same letter. Exactly. Good. And then how do you square 3 root 2? 3 root 2 to the 2nd power. How do you do that? Remember, you square the 3, that'd be 9, huh? And when it hits this guy, what does it do? Removes the root, makes a plane 2, so that's going to be 18. Over there, does that make sense what happened? Right, you square the 3 to be 9, you remove the root on the 2. So that, now how do you finish solving for x there? Divide by 2. X squared is 9. Last step to finish solving. Square root of 9 is 3. X is 3. The square must be side length of 3. So all the sides are 3 on a square whose diagonal is 3 root 2. Well, practical questions here. Okay, so Darla is building a new desk. To make sure she had made a square corner, she measures 7 feet from the corner along one edge and 9 feet from the corner along the other edge. How long should the diagonal be between those 2 points if the corner is a right angle? So in other words, I can simplify those. So what they're basically saying is she's got some kind of desk, and it's 9 feet here, 7 feet there, and they want us to figure out how long is the diagonal D. Does that make sense? That's what they're saying. 7 feet on one side, 9 feet on the other side. Right angle, find the diagonal. So can you do that? Can you find that diagonal D? So the Pythagorean again, a squared plus b squared is c squared. So which one is c this time? It's the d for diagonal or x or whatever you call it. The other two, 7. Yeah, so here's a rectangle like Claudia was saying. They're different now, the two sides, yeah. So that'd be what, 49, 81, 120, 130? And then last step is just to square root it. And then whatever your calculator says, 11.402, I rounded, 11.402 on that. We good with that? So that's it for this section. The other questions are review. Unfortunately, I don't have time to do review questions. I got a bunch of new stuff to do. The next one's a word problem, I'm sure. Be good to do that. Questions on this one? Yep, that was number 7. Yeah. Here's number 6 right there. Does that make sense on 6? Any questions on 6? Got that, Vincent?
Yeah.
Good. Anything on 7? We good?